The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
Okay. Now, I saw a number of sort of classic problems. People did equal signs for this when it should have been this. All kinds of stuff like that. And I tried to circle those for people to sort of remind them, hey folks, listen. Right? But I think in a lot of cases, the problems I noticed were problems that people didn't take into account. You don't know what's A, what's B, or what's C. How to assign that. And to blanketly say one conditional will solve this is wrong. You need to be able to say, I don't know if it's A and C. I don't know if it's A and B, or vice versa. And then it's B and A, B and C, and so forth, right? So this is all from a sort of how one would solve this problem, like the only possible way to go. Right? And that's really it. And once, if you can say, yea, verily that's true, then you can go ahead and say, I have a right triangle. Okay? So, anyway, that's what I saw in general. So if you had a comment that said, hey, conditional or logic failures, right? I was actually surprised at how many people didn't understand this. I mean, I even gave the equation. Okay? I mean, this is like fundamental math. Does that make sense to everybody? My friends, we're going to be looking at stuff a little more difficult than this shortly when we start talking about movement on the screen and so forth and so on. Okay? So you're going to have to do math. I don't care what you think or what you say. There's no such thing as not working with math. If you're in this field, that's a requirement. Okay? Any questions about that? If you have questions about the way your stuff was graded, please see me. Right? But I think I was a little generous on this one. Could have been much more vicious, like I normally am. Right? All right?
All right.
Anyway. My midterm's coming up across the street. Everybody's shaking already because they know it's coming. Anyhow, questions? Concepts? Anything? Like I said, if you have questions on how it was graded, please see me. All right? Other than that, we're going to continue on with our adventure in classes. Okay. So, let's see where we left off. Yes, sir.
What was the advantage of, like, so I was looking at the notes. What's the advantage of defining the input in the main? So the input is, you assign, so you have NBR equals the integer of input, how many bedrooms are in this house.
Okay.
Right? You can't have the input inside of the definition str. No.
Here's the problem. Okay, and we're going to really start focusing down on these ideas. Right? But one of the legs of the OO stool, right? Literally, I mean like the OO, they call it a stool, right? But here is the chair, so to speak, and this is OO. Remember, and I want to repeat this, I will repeat this throughout the semester, the remainder of the semester. Right? This paradigm, the object-oriented paradigm, you will learn it hook, line, and sinker, rote, I don't care how you think, right? this is the only paradigm. If you get a job in the real world, or think about getting a job in the real world, it's all OO. Okay, so, and I don't care what language you plan on programming in, doesn't matter, the message is the same. Okay, the concepts and so forth, right? But, so one of the legs is called encapsulation. The other leg is called polymorphism. There's one. And what's the other one? This is all in the text, folks. This is all in the slides. Come on. What's the other one? And that's the one that you're missing. It's part of this. Reuse. Okay? Reuse. And reuse means you write the code once and you use it all over the place. Right? And it's a very simple concept, right? Time equals what? Money. And if you're constantly rewriting code, you're doing what?
Wasting money.
You're wasting money. So if you put that into the get the information, give me the length or whatever it is, right? If you put that into the method, that decreases the reusability capability. That's why. All right? And we're going to be changing that up. Right now, I'm putting it into main. Soon, that stuff is going to be part of something called a get and a set. That's going to be part of the class definition. Right? So, like I said, the main is going to go like this, and everything else is going to go like this. Okay? But the idea here is that we want to write stuff that we can reuse over and over again. We don't have to reinvent the thing, right? You look at the problem, you go, oh yeah, I need a class for that, right? And when you think back on some of the stuff we've done in the class so far, in the course, I don't want to use the term class too much because I don't want to confuse people, but stuff that we've done in the course so far, using a class would have been a lot simpler if you guys knew what that meant, and be able to talk about it. Okay? Because remember, Project 3, all classes. So you're going to have to understand how it works, what it does, and why we're using it. Right? And you're going to need to talk about it in terms of at the level of the code. Not, well, I'm using this because it's for my ammunition. No, that's not what we're doing here, folks. Right? We're learning about code. I'm using a class implementation because I can reuse it. Right? And I can use the methods from that class to load my ammunition, remove the ammunition, all that kind of stuff. Right? We'll have a class called, for example, ammunition. We won't have to worry about the little things anymore because it's all going to be there because you wrote it all. Okay? All right. Any more questions? Like I said, we're heading in on all of this stuff. We're talking about it. Okay? So let's go back to the future. All right. Let's see if my stuff is working today. So when we last left, right, let's see what my notes say. Let's see. So it wasn't on Tuesday, right?
When we were talking about house and stuff, that was on Tuesday.
Right. Oh, house and house type. That's
Yes.
what's good. House and house type.
We didn't get into
Okay.
chapter.
We didn't get into chapter 8 yet.
No.
So let me see if I have my house type code with me here. I think I do actually. again, we're just philosophizing here. Here's my house type. I thought I said house type. Does anybody have a copy of it?
I do.
Bring it here. Put it on a stick. Oh, you got it on there?
Yeah.
Okay. That's here. I'll let you drive. All right, let's go back and have a look. Just to once again sort of review what we have going on. Why is my display not working? There we go. Set the options here, 16. So when we last left, we were looking at this. Come on now. Come on. It's flashing. Hey now. Bulb is going, but it's not. Aha. Okay, we're back. So again, let's just kind of take it from the top. So what do we got going on here? How many instances of house type do we have? And what are they?
5.
We have 5 instances. What are they?
House 1, house 2, house 3, house 4, house 5.
Okay. Right? Very good. What are these guys called?
What attributes?
Okay. They're attributes, but the reality is they're called actual parameters. Okay. In main, when you send values like that, they're called actual parameters. Up here, what are they known as?
higher than members attributes?
Up there?
Are there arguments?
No. They're what? They are members, but in this particular case, what I just said, right, I said inside those parentheses, right, in the definition, they're known as what? Formal parameters. Formal parameters. Okay, but they are the members, you are correct, right? What does the term self mean? What does the term self mean?
Isn't it basically like a way of localizing it specifically to the thing? So it just goes off itself instead of trying to be a global parameter or whatever?
What thing are you talking about?
Wherever you put self, so like self.bedroom makes it only inside the bedroom thing, right?
So let me put it a different way. Go ahead.
Is it referring to the current object? Like,
It refers to the current object. Right? Somebody's got a little right? How you doing so far? Are we on track with what you understand?
yeah.
Okay. So self, in this particular case, is who? In this block here. House 1. Self here refers to house 1. Here is house 2, house 3, house 4, and house 5 ultimately down here. Right? Self refers to that instance, that object. Okay? Does that make sense? The term self. So when we do this right here, and we're displaying the members, the values for those members, in this particular case here, right? Because remember, who does this, what method does that call?
Calls the define string method. Or, I'm sorry, just underscore str.
Yeah.
Underscore.
Right? It's the status method. Tell me what the value of my members are now. Okay? It's one way of looking at it. But self here, in this particular statement, refers to which members?
NBR and ST.
Correct, but which, for which instance? House 1. Down here, it refers to house 2. The values for the members of house 2. Right? And then the same thing for print 3 would be the values of the members for house 3. And so forth. Okay? Is everybody with me here? So, we've talked about this guy. What's this guy known as?
Constructor.
It's the constructor. It's the general contractor, right? It's the one that's responsible for building the structure in memory. Okay, underscore, underscore, INIT, underscore, underscore. Okay? Does it make sense? So, we're at that point now. Ready? Let's make that jump over to the chapter now. Chapter 8. So we can round out the conversation a little bit. Okay? So, let's go over here. And let's look at chapter 8 slides. Yes, sir.
What were the attributes and the parameters of the constructor called again?
Well, any function definition, right, those are called formal parameters. Formal parameters, but they are also the members. They're the attributes. And that's how it's set up in Python. So, chapter 8. Let's go back to chapter 8. now that we've had this little discussion, let's come back and take a look at it in a real simple form again. Okay? Because there's a few things we haven't talked about yet. As a matter of fact, let's close this guy down for a while. Let's open a new Python session. While this is booting up. All right, so let's take a look at our little conversation, and it's all about critters. Okay, so here we are. Right? We talked about the OO, we talked about the attributes. Right now, let me say that, and I've already sort of intermixed these two naming conventions. Right, attributes. The newer terminology is members. Okay, they're one and the same, and we're going to probably mix them up a few times yet as we're going along. Right? We know what a method is, we know what an instance is. To instantiate, to create an instance of the object, we have to call the constructor. Right? You got to call the constructor. Right? This goes through all of these kinds of things that we've just talked about, right? So let's go out and let's step back just for a minute and talk about something a little different now, okay? So here's a really, really, really simple class definition, right? It's so simple, it doesn't have a what? What's it missing?
It's missing a constructor.
Constructor, right? So, if you have no constructor in your class definition, what happens is the system says, hey, you don't have a constructor, so I'm going to give you what's called the default constructor to use to create your instance of the class. And it's okay, but like anything else like this, right? And we've seen this sort of move before, when you create the object, right? What you're going to get is nothing more than a blank space of memory, right? And that's literally what's happening right here, right? So what's the instance there? Or what's the object? All no.
What is the object?
Crit is the object. It's the instance of the critter class, right? This is the class. And just like before where we said house 1 is equal to house type something blah, 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 same thing here. Crit equals critter. Okay? This is the class. This is the instance, the object. So the current instance is what? Crit. And by the way this is set up, okay, we can directly call the method, right? The methods that we've been using up to now have underscore, underscore something, correct? Are you with me here? Constructor, the status method, the underscore, underscore str. We don't have any of that, right? All we have is this talk guy. So we can use what's called the access identifier, right, the period, to say, here's my instance, dot talk. Instance dot talk says I'm going to call this instance and this method, okay? Because remember, what we're actually looking at here, right? So we have this object. It has no attributes or members. All it has is what? One method called talk. That's it. So this is crit, and crit has one method. Boom. Every object you make of that class definition will have, in this case, one method called talk. Its own copy of it, actually. Right? Does that make sense to everybody? So if I make 5 copies or 5 crits, crit 1, crit 2, crit 3, crit 4, crit 5, or however many million I'd like to make, every single one of them will have the one method called talk. All right? So let's execute this code. Let's fool around a little bit. All right? So I'm grabbing this code. You're going to have to make some adds to it, remember, because it's 2.5.2.6 syntax, right? So you have to put parentheses around this. Right? I don't like this, right? Because you cannot get away from the using a main, right? The minute you start walking away from that, you're asking for trouble. Right? I mean, the purpose of main is to become your client, okay? Okay, so I'm going to run the code. Desktop. And we should see, hi, I'm an instance of the class critter. Does everybody get that when you run the code? All right, we're doing the simple stuff. There's one more thing up here. I'm just going to mention it. We will come back to this idea because that's really part of the beauty, if you will, of OO, right? And that's this thing right here. It's called object, and it's in between the parentheses. Okay. We haven't gotten to this yet, but we will. It's coming. Object represents as an identifier for a base class. Okay, we'll talk more about that, but the term object, in case anybody's wondering, because in our house type definition, we didn't have this, did we? It just had the two parents, and that was it. Okay. Now you have this thing called object, and that's, like I said, used as an identifier for a base class. Okay. We'll leave it at that for the minute. All right, so this talks about all of the stuff that we've been dealing with already, methods, how to call them, instantiating the object, invoking a method, right? No constructor, you get this, it's blank memory, and if for the moment that's fine, we have no attributes, right? Does that make sense? We've seen this before. Where else have we seen this? I'll let you think about that one when we continue on. Okay? Constructor, right? No problem. We're all good. Right? So let's put a constructor in now. I'm going to put a constructor in. Right, so I'm going to put him sort of in the proper order. Right? Yes, sir.
Aside from the constructor being on top, are there other methods that have to be in order under
No.
the constructor?
Here's sort of my philosophy on this, right? I like to have a standardized layout for my class definitions, right? Because your definitions are going to go like this. Because we got a whole bunch of methods that we're going to be putting in for the classes as we go along. I don't want to have to look through a whole page worth of methods if I want to find the constructor. Constructor, to me, usually is right at the top because it's what's creating the object. Right? But it's not a written rule, right? It's sort of a de facto standard. Right? Anything with an underscore is generally at the top of the class definition. Okay. So let's run the code again. We have our own little constructor. Right. It's not going to do much other than print another line when we go ahead and create that instance called crit. we could do this. We create multiple objects, right? We've done this, house 1, house 2, right? Crit 1, crit 2. Concept is the same. It's just the names have been changed to protect the innocent here. Okay. Not even a smile, really. Jeez. You guys all missed the sort of, the names have been changed to protect the innocent here? All right. Let's get some attributes, some members out there. We're going to start out with the first one. We're going to add ourselves name. It should look pretty familiar. So I'm going to modify this guy here to add name to the picture. I don't really need this line anymore. So if I would like to see the name in my output, I don't have an str method, for example, right? But I could create one pretty quickly. I could just go right back out to my old code on the desktop here. Grab my str method and doctor it a little bit so that it's relevant to what I'm doing. This time, critter instance, and here are the member values. And in this particular case, all we're going to say is name and self.name. And oh, by the way, I don't need to change this to a string anymore because it's what? It's already a string, right? So we'll get rid of these guys for a moment. This fella here. And we'll run the code. Oh, it takes 2 arguments, 1 argument given. So now I need to add something. I'm going to add Randolph. It's a nice name. I like that name. And I'm going to print crit. So this line onto itself here, print crit, right, is going to call who? And don't say Ghostbusters.
The object.
We're going to call this guy here. When we say print crit, we're going to call the status method, and we're going to send it the instance or our only object so far, crit. So let's see if it works. Maybe we're out of luck here. It works wonderfully. Okay. So here's what I want you to do. I want you to create 2 more instances right now. 2 more instances of critter. I don't care what you call them. Give them different names. Update the status method that's up there and run the code. Actually, I'd like you to add a couple more things to that. Not only a couple of instances, I'd like you to add a couple more members. Like, so maybe a color and maybe number of legs. Okay? I'll be back. I'll be back. Thanks. No problem. Thought you were going to submit your code already or something.
Have a think about it on the way over. Thank you.
No problem. So I want you to create 2 more instances and add a couple of attributes. Like one could be like color, maybe number of legs. It's clear we don't know whether it's a spider or a squirrel or I don't know. Does that make sense? Who's got it done? Got it done? Lead the way. Any one of those slots. There we go. Okay. Thanks. You do me a favor, copy that to the desktop and then take your stick. Thank you. All right. How's this measure up to what you were doing?
or like it'll print, so I can do it again.
That would help. And then you got to update something else too. You got to update your status method. Underscore str. Okay. And it doesn't have to be string anymore because name is a string. Right. I'll give you another minute or two, and then we're going to make some more changes to this. Everybody all right? Is it working now?
I don't get what you mean by update this status.
The output, right? When you say print instance, right? This guy here, you've got three things here now. You only have one on the output.
So I need. Okay. Okay, I got you.
Doing all right?
Okay.
You doing all right? Doesn't look like it. Got some stuff happening there. What you guys doing okay? See some errors going on there. Look at your code compared to that code. Going? Yeah.
Hey! I did it.
I'm telling you, I think half the problems that people have are keyboarding issues. I think you should all be going to Typing 101 or something to improve your typing skills.
Definitely.
Anyway, so let's go back to the material here for a second. Right? So we've gone ahead, we've done this, initializing the attributes, right? We can go ahead and send the values, right? The talk, accessing the attributes, right? Here's the thing that's kind of interesting. Right? You can do things this way. Right? I want to print the value of my critter, a value of one of the attributes of my critter, like this guy here. And I can say, it's not crit one here, it's just crit. I can literally say print crit.name. And this is going to bring up a whole new avenue for discussion here in a second. Right? So I can run this and I can get to the individual member of a particular instance. Does that make sense? Questions about that? So I'm actually able to get the name. And like we always say, if I can print the name, I can do what with it? I can catch it and look at it, examine it. All the stuff that we've been doing all along up to now, I'm now going to be able to do against these values. So let's update our little chart here. Right? So now, right, our crit has a constructor underscore init, has an str method. It still has the talk, and we have what, 3 members, right? We have name, color, and size. Does that make sense? So every instance of the class, now every object will have this. Right? So crit n. Every single critter object that we create will have those elements in it. Questions on that? So, 3 members, 3 methods. Talk, constructor, and str. Any questions? Right. And we can get a particular member, right? I'm able to get a particular member right here by simply giving the instance name and the member value, whatever it is, okay? And I could do that for any of them, color or number of legs. Right? Questions on that? So here's where it gets interesting. Right? We have this. We're doing this guy. Right? Class attributes. Let's add something now. This is different than what we've talked about so far. This is called a class attribute. It's not a member, not a attribute of the class instance. It's a class attribute. Okay? What exactly does that mean? That means this guy here, for example, and doesn't matter what I'm calling it. It's a class attribute. I could call it Frank. It doesn't matter. The word total has nothing to do with anything other than it's relevant to what we're about to do. Okay? And this is the part where I think you guys might find some interest. Right? I'm going to, right underneath this guy, add my total. It's supposed to be total. Equals 0. Okay? And what this class attribute is going to do is it's going to keep track of how many instances of the class I have currently existing. So in my constructor now, I'm going to add another line of code that says critter dot total equals critter dot total plus 1. And you might say, what does that mean? What are we doing here, right? Like I said, this is going to give us the option or the ability to keep track of how many critter instances we have out there, right? So I can do it both ways now. It is a class attribute, which means all instances of the class, number one, has this information in it. Okay? And I can interrogate the class itself for that value. How many things I have. Let's see what that means. Right, so here I am. Right, I'm going to go out and do this. And I'm going to sort of document what's happening. So here, print. This is now the class at the class level. And then I'm going to say, the other way of finding out what it is, I can look at it at the instance level. In other words, I can check any instance of the class now, and I will get that information. In other words, how many critter instances do I have? Ready? Let's check it out. What value should I see?
3.
In both cases, I should see the value 3, except I have a problem. What am I not doing? Print needs to have parentheses. Sorry. Lousy grammar rules. Who came up with that title? Let's run it again. Have a problem at the instance level. Why is that? Why do I have an error there? What's that? Because is there a crit 1 out there?
No.
Nope. So now we should be good. Let's see. Look at that. So I can interrogate at the class level if I want. So I could literally set up a method that would look at that value and say, if I have more than 100 critters out there, stop creating them. Or if you only have 5 critters out there, create 5 more. Right? Do you understand what I'm saying? And various instances of the class can talk to each other. It can keep track of themselves. So if I say I need a wave of enemy objects to be created, 50 of them, right? It's pretty simple to figure out how many I have, right? All I got to do is look at that value right there, and it will tell me that.
Would you put that condition right underneath where you define that variable? Or you
Nope.
put total?
As you notice, I haven't done anything yet with that problem, right? So far, I've just displayed the values. You can start testing that concept out, right? All you have to do is, if I can print it, that means I can grab it. And I could just say if critter.total equals 3. I'm just going to print a comment, right? Print. Might need to create a few more. Does that make sense? I'm taking a look at that. Okay. So let's see what happens if that works. Should we see something? The answer is, if you do the right syntax, you'll be maybe golden. Might need to create a few more. More importantly, remember what I said, you don't want to put any of that kind of logic into maining. You want to minimize that stuff. So we probably should create another method here. Right? I'm going to call it DEF. Add enough. Have enough. Right? And all that's going to do is this guy here, right here, because I can interrogate internally to the class, because total is a class member. It's like, where have we seen this before? It's not inside of a function. It's at the top of the code. What do we call those? What did we call those? Huh? Globals. Thank you. So I can do this, and then I can say return. Excellent. See if it works.
If should I what?
See if it works.
Have enough is not defined.
What are we going to do?
If should a critter period don't have enough.
It needs to be crit dot. You got to give an instance, right? Everything else requires an instance. Crit have enough. Takes no arguments, one given. Ah, what's the problem? What is the problem here, my friends?
Crit isn't an object.
You don't have self.
Gotta have self. And again, I'm just fooling around with functions and stuff. I'm just experimenting around. But I've created a new method, right? And that new method, I'm going to call have enough. Have enough says, I have a little switch called need more equals false if critter.total is equal to 3. Crit might need to create a few more. Need more is equal to true. Return need more, which is now going to be set to what?
True.
Well, need more is set to true, but on the return trip, what is that return value going to be assigned to? Should I? Right? This says, right here, I'm calling the function, the method, have enough, instance crit. Okay. Remember, the value of total is known to all instances and the class, overall class, for how many instances of crit we've built. Right? So I'm going to return the value if it says true. If should I, right? Going to do it. What data type is should I? What data type is should I? A what? Well, what is the data type of this right here? It's a Boolean. It's true or false. And I'm just saying, if should I? In other words, is it, if it's true, do something. I don't need to say if should I is equal to true. I'm cheating. I'm doing what you guys would do. I don't want to type so much.
Where does it determine if it's true or false? Like,
What do you mean?
if something happens. So if critter.total equals 3,
Right.
need more equals true. Where is, so you initialize need more to false.
Yeah.
Okay, what?
If critter.total is equal to 3, I create a little comment, and then I change the value of need more, which was false, to true, and then I return.
Oh, okay, and then you said you cheated down there, so.
I cheated down here,
true.
and I didn't say if should I equals true. I took a little,
Yeah, I get it. Okay.
and you can only really do that on a Boolean.
Yeah. I got this all.
Does it work?
Yeah.
You got your code working? But what am I able to do now? I'm building some control mechanisms in, right? And I want you to think about this because you wrote some code recently that talked, some people wrote some code recently that talked about level, right? And you could say, depending on the level, in this case, if I have only 3, let's get 5 enemies out there, right? The system manages itself. Does this make sense? Very interesting, right? And you can manage the entire program by doing this sort of thing, right? But you'll also notice, and right now I have this guy in here like this. Normally what this would be is it would be calling a function. There wouldn't be a print statement there. You'd be calling a display function or display method. Remember, we still have functions outside of classes. right? We have still generalized functions out there that we can use. And so these are called what? Methods. We can still have functions outside of classes. And you will. You're going to have lots of them, just like you did before. Continuing on. Okay? We are just having so much fun, I can't stand it. Right? Accessing a class attribute, we just did all this. Right? Yes?
What is the benefit of still using a function outside of a class?
Lots. As much as it used to be before. Right? Think about what's happening. Okay? You were controlling your program using function calls, right? And then we brought along some data structures. We did tuples, lists, dictionaries. They didn't contain functionality. Now, we got these guys. These are completely self-contained. They have members and methods to manage the object. We've just stepped up the rung on the ladder with regard to data structures, my friends. Majorly stepped up. Okay? So now you've got this self-contained package. Think about 5 or 6 or 100 classes, potential classes you can take advantage of. You can have a hero class, an enemy class, an overall game class, right? Which we're going to have, and stuff like this, right? And those will be self-contained. They'll be self-contained. Create the instance, you're done. Next. What do you want to do next? Okay. As I said, these are really, really, really simple classes. I mean, we're not doing anything here. Zero. I mean, literally, we're creating the object and show me what their contents is. We're not doing any logic. So let me throw this out at you. Okay? You're going to be crafting classes where each of the classes has their own behaviors. In other words, their way of moving on the screen, their protective mechanisms, right? How the collision works. Those are all nothing more than methods inside of the class definitions. So when you create the object, it's all done. One statement. House 1 equals house type. You get it all in one shot. You can create 50,000. Right? Every one of the instances of that class will have that information. The attributes and the methods to execute those members. Okay? Doesn't that sound interesting? You're going to love it. You are going to love it. You thought debugging was fun before? We're just starting out, boys and girls. So you all want to be game developers, eh? I'm just kidding. All right. We're going to come back to this concept of a static method, primarily around the fact that it's a little early to introduce this. But we'll come back to this. Multiple instances. All right. So let's get into the philosophy here of the whole OO approach, right? And I brought this concept up earlier. And what does this mean? And we've been practicing this, believe it or not, all semester long already, right? And this is the idea of a separation of the definition and the implementation. Okay. What's going to end up happening is you're going to have one code file that's going to contain your main, your client, and then you're going to import all of these other code files that are each or depending on how your code looks, will have either a file for each class definition or a library of classes based upon what you're trying to do. Okay? So we're going to be practicing this encapsulation concept. We're going to be separating the definition and the implementation from the main. All you're going to know in main is, how do I get this information? How does it work? All right? So I'm going to step back for a moment. I'm going to turn the clock back. And I'm going to take you back to some of the data structures we've seen recently. Think back to the list data structure. What did I tell you when I said the functionality for a list? What did I call those? They were methods. I said list name dot method. Remember this? And you saw that little table that said for an insert you needed to supply the location and the value you wanted to insert into the list.
Yes.
You had no idea what was going on underneath the covers on how that was being implemented. But all you know, or all you knew at the time, was list dot insert and then the arguments to go in there. Guess what a list is? It's a class. The minute you hear method, you should automatically think class. Right? Does that make sense? And that also was the case with the dictionary. Remember that? Remember those guys? The key value pair? It had its own set of methods. Right? Dot something, access specifier. That dot represents a method. Instance dot method name. Okay? Does it make sense? It should start clicking here pretty soon. Because we're doing it right here. Right? If you look into this code, you'll notice that that's what we're doing. Right? Here's an example, crit.name, but that's really not. This is actually a much more of an example of what I just mentioned. Give me the instance, dot had enough. Had enough is a method of the critter class. These are our own handcrafted classes. In that case, the list, right, that's a system designed class. Right? Does it make sense a little bit? That's the direction we're going. So let me give you a little advanced commentary. Ready? Take a guess what Pygames is. A giant class with hundreds and hundreds of methods in it. The first thing you're going to do when you start using Pygames, ready? Here's the opening statement when we get there. Look familiar? You're going to create an instance, a local instance of Pygame in your environment. Then, guess what you can do? Once you create the object, what can you do?
Use all the methods.
You can use all the methods that are available as part of the library, part of the class. Right? Starting to click a little bit?
A lot.
Good. Like I always say, I can smell the straw burning from here, right? Anybody know what that refers to? Seriously? You guys are all deprived people. Like really deprived people. You ever heard of the Wizard of Oz?
Oh,
attention to the man
because his
behind the
brain
curtain.
power, yeah.
Right? The straw man. Anyway. Oh my God. You guys got to get your heads out of games, man.
The scarecrow?
Yes, it's destroying your mind.
Oh,
I feel like a really old guy. Anyway, so if you go out to, for example, pygame.org, guess what you're dealing with in Pygame? Right? All the docs, right? All of the methods from the Pygame class, the Pygame library. Right? Import and initialize. Import Pygame and pygame.init. Pygame is so old they didn't even have __ yet. That's how long this has been around. Okay? We'll come back to all of this stuff, but I just wanted to sort of give you the reasoning for the madness here. Okay? Yeah, there's all kinds of great stuff. That's your next best friend, right after the python.org. Okay? So let's go back to this guy, right? So encapsulation, the client code, guess who the client is? Who has been our client all along?
Player.
Main.
Oh.
Main is what's creating, it's taking advantage of all the stuff that's out there, right? And the objects, right, once you create your objects, right, you can call the methods that support them. Okay? Let's go to this next topic. This is kind of a tough one to talk about, right? Up until now, right, everything we've dealt with regard to our members are what's called public attributes or public members. Okay? A public member is a member that you can go directly at and get the value from, right? So an example in our current code would be this guy right here. Crit.name. Name is an attribute or a member, right, of the class. I can go directly at that guy and get the value. Okay? That's called a public attribute. Okay, public member. On the other hand, there are times when you don't want to have that. You want to protect that attribute or member, right? And that's called defining it as private. Yes, sir?
Would it be like in a game where you have certain actions that are locked unless you enter in a specific code? Like a cheat code, if you will?
I doubt if they're using this technique for that. It's just a conditional, more than likely there, right? But an example of something like this, and it's, again, it might be a little bit dated because I think this information is just out there for everybody, would be like Social Security number, right? You don't want everybody to go and get your Social Security number, would you? You'd want some special something, some sort of security on that information. So you would want that to be designated as private. So, if that's the case, that's what they're talking about here, you'll notice this right here, __ in front of the attribute or member name. That's an indicator for a private attribute. You might say, well, okay, I said it private, but it's mine. I want to be able to get at that member. So the rule is the following. You need a public method to go against a private member. And actually, the better way to do it, right, is to actually have a private method as well. And a private method we've already seen. That would be your constructor, or that __ str. Anything with __ in front of it is private. So the preferred way to do this, right, would, if you have a private member, have a private method specifically to get that value, put it into the private method, and then a public method that will call the private method, right? Does that make sense? That way, you can put a password or some sort of security string into the private member or private method. Right? Does that make sense? Mm-hmm. Question?
Yeah. So for so if each of the private things are defined by the _, doesn't matter if it's in front of, behind, or both.
Got to be in front.
Okay.
Has to be in front. Okay. So private member, private method, public method to call the private method. Okay. That would then allow you to put some sort of, for example, password on that if you needed to. Okay. And you can see what they're doing here is they're actually using, they're going after the private method here, using a public, this talk method. It's okay, but you really can't protect against that. Right? You really would prefer to have a private method that you can add another attribute to that can be tested prior to getting that information and returning that information on a return statement. Yes, you have a method that calls a method. That could call another method. That could call another method if you wanted to, right? You're the one designing the code. Okay. Questions, comments? It's getting exciting, right? Lot to think about now. Lot to think about. Public method, and as you can see, here's the public method. This is a public method. It's calling the private method. Self.__ private method. So what is that private method now being considered as? A member of the class. Now we're mixing up members and methods. Technically, methods and members are all considered as members. Okay? If you look at the technical definition. For our small minds, members and methods separated, it's just perfect. Okay? For a while, we're going to continue doing public members. Okay? But we're going to get to a point where we're going to have to hide some information from the different characters in the games. Right? Just to give you some experience with this. So, let's talk about your homework. Let's talk about that homework. So here's what I want you to do. I would like you to take 2 of the new members that you just built. Right? Okay, use that example. What I want you to do is add 2 more members to this that we're working on right now, our little critter class. And I want you to make one of those 2 a private member. Okay? So you're going to have to create a private method that can be called from a public method. And I want you to display the value. So you're going to need a special __ str method to do that. Does that make sense? So 2 more members. 1 needs to be private. Okay? And then I want you to create a public and private method to get that information from that private one. Okay? Shouldn't take a lot, but you're going to have to think through the problem. Okay? Does that make sense? We have to get really solid on these ideas, folks.
So you just need it to be callable from the public one?
The private member?
Yes.
Yes. I'll leave it at that. Right? I'd like to see it being called from the main, but it's okay. Call it from another public method. Okay. Just so you can get the value, I want you to display that value, the private value. Does it make sense? Questions? So, with that, this is all that stuff. All right, so when we come back, we're going to start out with gets and sets because we need to get that straightened out. All right? Gets and sets. All right, if you have questions, stick around. If not, I will see you on Tuesday. Yes.
So let me just get this straight. We need to make 2 more methods, 1 public.
No, 2 more members.
2 more members, okay.
1 has to be private. I want a private method to call the private member, and then a public method to call that private method. Okay. It's It's getting complex now, eh?
Yes.
Oh, man. Guys, your eyes are going to roll back in your head.
Pretty soon.
Just warming up.
Tuesday, Professor.
See you then.
That's the real scary part.
What's that?
Every time we're like, oh, this is nothing.
This is nothing. I'm just reviewing the Project 2 code. I'm trying to get you guys ready to start reading that. 'Cause that's our first jump into Python Project 2, which is in about tops. Not next week, the week after. Next week we're going to Blackboard. Or Blackjack, not Blackboard. Blackjack.
No, that was there.
That's why I wasn't there.
Code's going to get bigger and bigger and bigger and bigger.
So it's, although I do like the idea of just being able to have everything in different files and putting it all in there. That sounds like it would be interesting.
All right, this time I'm going to try and keep this.
Talking about toolboxes and figuring out how to create set toolboxes.
Oh, yeah. We are having fun.
Take a picture, text me a picture of I know, I didn't
So where are we submitting this to?
I'll tell you what, the 10th. I'm definitely.
Take a picture of the homework so I can see exactly what it is.
It's just,
Are we submitting this to OOP1?
No, OOP1 is another set of information. It's a whole other slide set.
Okay.
I got to actually do a Dropbox for this.
Right?
Gotcha.
That's right.
Might actually be out with me.
Yeah, I was trying last night. I had to go leave and pick up my little sister, but I was trying to make for my chemistry class. I was trying to make a program that'll balance the equations.
Good luck with today's lesson.